All right, this is lesson 16. We are talking about how to compute actual lengths from a scale drawing. So the first example is a basketball at recess. We talked about this question yesterday. We just didn't figure out what the dimensions actually were. We were just looking at scale and scale factor. So today we're actually going to look to see what are the dimensions of the actual basketball court. So I'm just going to remind you the question says that the empty lot is 25 by 75 and it wants to know, will it be big enough for the court that he plans? So that's what we're actually answering today. So we are going to find the actual dimensions. We know the scale drawing dimensions because they are given to us right on the scale or on the picture. And we're going to find the actual dimensions of this basketball court. So one important thing we know from up above, it says that the scale, okay, on this drawing is 1 inch equals 15 feet. So that's the scale. That's going to help us determine what the actual dimensions are. So if you look at the chart, I kind of set up a chart to help us organize our data. So the actual dimensions is 15 feet. The scale length is 1 inch. I'm going to zoom in on this so that we can see this a little better. So we know from this picture that the length, okay, if you look at the picture, the length on the scale drawing is 2 inches, okay? I put a box around that already. And the width is 1 2/3 inches. I already put a box around that. Notice that we are trying to find the actual length, the actual width. So what we're going to do is we're going to be setting up proportions for all of this. So we're going to set up the proportion. We're going to solve to find the missing values. So I'm just going to remind you that we are going to do drawing over actual. I'm going to abbreviate that to D, drawing over actual. So in the drawing, we have inches, and in actual court dimensions, we have feet. This is going to be another important piece of information that you're always going to want to use. So inches over feet. That means all inches are going to go on the top of the proportion. All feet are going to go on the bottom. Now, the first fraction always comes from our scale. So we have 1 inch, 15 feet. You don't have to write the dimensions. You can just write the numbers. Equals. Now we're going to focus on the length first. We are given the number 2. That's number of inches. So that's going to go on top. And X is the number of feet. We don't know how many feet it is. That's what we're trying to find. So that's going to go on the bottom. So this right here is called a proportion, and we're going to solve this. Before I do that, I'm going to take a little arrow for our notes. This right here, this first fraction, comes from the scale. So this number, this fraction is the scale. All right, so how to solve this? We are going to cross multiply. So that means we're going to take the numbers opposite each other, so 1 and x, and we're going to multiply. So 1 times x gives us 1x equals, and now we're going to do the 15 times 2. 15 times 2 is 30. Now 1x is the same thing as x, so we know that x is equal to 30. So we can go back up to the chart and fill in 30 feet as our length. Okay, now we're going to do the same exact thing, but we're going to find the width. So we're still going to use inches over feet. I'm not going to write that again. Our scale still goes first, which is still 1 over 15. This time the number of inches is 1 2/3. That goes on top of our fraction, and we are trying to find the feet, which would be x. So we're going to cross multiply to solve. 1 times x, remember that's the same thing as just x. And 15 times 1 2/3. Now we're going to do that in the calculator. Remember, you're going to enter the, if you have the old calculator, you're going to use the ABC button. If you have the new calculator, you're going to just use that little mixed number button. So 15 times 1 2/3 gives us 25. Now that x is on the bottom, that means we're talking about 25 feet. So I'm going to go back up and I'm going to fill that in the chart. So now we can answer the question. Okay, the question says, will the lot be big enough for the court? Now the court is 25 by 30 feet, okay? We get that from down here. Let me highlight it. So 25 by 30 feet, that's our dimensions of our court. The lot is 25 by 75 feet. So that means that that will fit on the basketball court, so, or on the lot. So we would write yes to this question. Okay, and you could probably explain it by saying that the court is 25 by 30 feet. This is 25 by 75 feet, so there will be enough room. All right, next question. All right, in example 2, the diagram shows a garden. So we know that 1 centimeter is equal to 20 meters. That's our scale. It says each square in the garden measures 1 by 1. So find the actual length and actual width. We're going to do this today. We're going to answer that question. So down in the chart, we know that 1 centimeter in the drawing is equal to 20 meters in actual garden space. So I'm just filling in the scale first. Now, we do know in the drawing what our dimensions are, because remember that each of those squares is 1 centimeter. So if I count them from here to here, if I count those squares, 1, 2, 3, 4, 5, 6, 7, 8, there are 8 squares, which makes it 8 centimeters. Now on this side, this is our width. There are 4 squares, which makes that 4 centimeters. Now that's in the drawing, so that means my length is 8, my width is 4. So I'm going to fill those in. Now I'm going to set up a proportion to solve for the missing values, the actual values. So remember, it's drawing over actual, okay? So that means in the drawing we were measuring with centimeters. Actual dimensions were being measured with meters. So centimeters over meters. Now remember, we're going to start with the scale first. So 1 over 20. So I'm just going to put that is our scale. Equals, now let's do the length first. So they give us 8 centimeters. Centimeters are on top, so we're going to put the 8 on top. X goes on the bottom. And we're going to cross multiply to solve. So 1 times x is just x. And on this side we have 20 times 8, which is 160. So that means the length, the actual length, is 160. Now that x is on the bottom, which makes that meters. All right, let's do the next one. We're going to use 1 over 20 as our scale again. This time the width is 4 centimeters. 4 goes on top, centimeters go on top. We're going to cross multiply. So 1 times x is x. 20 times 4 is 80. We're talking about the actual dimensions, which makes that 80 meters. So the question is find the actual length, actual width. We did that. Here's our actual length. There's our actual width. All right, let's move on to the next one. Example 3 says a graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 0.25 inches on the scale picture represents 1 inch on the actual advertisement. What will the length and width be on the advertisement? Now you can't see this. We're going to have to fill this in because it got lost in the computer. So that's 1 1/8 inch, and this one is 1 1/4 of an inch. All right, so find the actual length and actual width. So we're going to start by doing drawing over actual. Now if you notice, our scale is 0.25 inches in the drawing, represents 1 inch in actual advertisement. So I am dealing with 2 sets of inches. So we're going to have inches over inches, but to identify what is what, I'm going to put the D next to it and the A next to it for actual and drawing. All right, so we're going to start with the scale. The scale is 0.25 in the drawing, is 1 inch in actual advertisement. And we're going to do this one first right here. That's going to be our width. We'll find the width first. Now that's 1 1/8 inches. That's in the actual drawing. So I'm going to put 1 1/8 on the top. and we're going to find the actual dimension. So I'm going to put x on the bottom. Now I'm going to cross multiply. 0.25 times x is 0.25x. 1 times 1 1/8 is 1 1/8. And now we've come to an equation that we have to solve. So we want to get that x by itself. So the only way to do that is to divide both sides by the number in front of the x, so 0.25. That gets rid of the 0.25s, and we're going to take our calculator to divide this. So 1 1/8 divided by 0.25 gives us 4.5 inches. So that's our width in our actual dimensions. All right, so now I'm going to do, change colors here. Now I'm going to do the width. I'm sorry, I just did the width. We're going to do the length, which is 1 1/4. So we're going to start off with our scale first, 0.25 over 1. And our dimension is 1 1/4. That's in the drawing, and I want to find how much that is in real life. So 1 1/4 over x. So 0.25 times x gives us 0.25x. 1 times 1 1/4 gives us 1 1/4. Here's where we're going to solve. We're going to divide both sides by 0.25. The 0.25s cancel out, so I'm going to take my calculator, 1 1/4 divided by 0.25, and that gives us 5 inches. So we have two dimensions that we just found, the length and the width. One is 4.5 and the other one is 5 inches. All right, next example. It says a scale on the map is 1 inch is 25 miles. So the length of Lockport Road is 37.5 miles. What would the distance be on the map? All right, so remember we're doing drawing over actual. To do this, we're going to set up a proportion. So we have inches and miles that we're talking about. So inches is the units on the map, the drawing, and the miles is the units in the actual road, of the actual road. So we start with our scale, 1 inch over 25 miles equals. Now this number they give us here, 37.5, that's the number of miles. So that's going to go on the bottom. X is going to go on top. So we're going to cross multiply to solve. 25 times x gives us 25x. 1 times 37.5 is 37.5. We're going to solve for x. So since 25 is next to the x, that means multiplication. We're going to divide to get rid of it. So I have 37.5 divided by 25, which is 1.5. And we're talking about 1.5 inches because that's on the map. It's 1.5 inches away. All right, example number 5. It says a barn is 30 feet by 100 feet. What's the actual length and width if the scale is 1/2 of an inch equals 10 feet? So I'm just going to draw this for you so that you can see what's going on here. Okay, it says the width is 40 feet wide by 100 feet long. So we're talking about two dimensions here. So two dimensions means we need to set up two proportions. So we're going to start with drawing over actual. Now we're talking about inches and feet. Inches is in the drawing, feet is in actual life. All right, so let's start with just the length. So our scale is 1/2 of an inch is 10 feet. So the scale always comes first. We know that the length is right here 100 feet. So 100 is going to go on the bottom because that's the number of feet. X is on the top because we're finding the inches. So 10 times x is 10x. 1/2 times 100 gives us 50. We're going to solve by dividing both sides by 10. The 10s are going to cancel out. So we have x equals 50 divided by 10, which is 5. Now that is 5 inches because that's in the drawing. All right, so let's talk about the width. So same scale, 1/2 over 10 equals. Now, this time the width is 40 feet. So the feet goes on the bottom, x goes on top. So 10 times x is 10x. 1/2 times 40 is 20. Now let's solve for x. We're going to divide both sides by 10. So x is 2, and that's the number of inches in the actual drawing. So our answer, we had to find the length and the width. We found the length in the drawing to be 5 inches and the width in the drawing to be 2 inches. All right, I'm going to have you try the next couple examples on your own. I want you setting up proportions and solving them, but I want you to pause the video, try them on your own, and then hit play to make sure that your answers are correct. All right, so exercise 1, it says that the distance on the map between these two cities is 4 centimeters. Here's the scale, 1 centimeter equals 24 miles. We want to know the actual distance. So we're going to set up a proportion, drawing over actual. Now, in the drawing, we're talking about centimeters. The actual dimensions are in miles. So we have centimeters over miles. The scale goes first, so 1 over 24, that comes right from the scale. And the other number they give us is 4 centimeters. 4 is the number of centimeters, so that goes on top. And we're finding the actual distance, which is miles. So we're going to cross multiply. 1 times x gives us x. 24 times 4, I'm going to use my calculator on that. 24 times 4, which is 96. Now that's on the bottom, so that's 96 miles. It was the actual distance between those two cities. All right, exercise 2. Here we have the scale that's given to us right here. We know the actual distance of the butterfly is 4.5 centimeters. We want to know the actual width. So drawing over actual, okay, we're talking about centimeters and millimeters. So I get that right from the scale. That's how I know what my units are. So I know it's 0.25 over 1. Okay, that comes from the scale. 4.5 is the number of centimeters. That goes on top. And I want to find the number of millimeters. So we're going to cross multiply. 0.25 times x is 0.25x. 1 times 4.5 gives us 4.5. And we're going to solve. So we want to get rid of the 0.25 because we want to get x by itself. So 4.5 divided by 0.25 is 18. That's on the bottom, so we're talking about millimeters here. The actual distance of that butterfly is 18 millimeters. All right, last one, exercise 3. Okay, so this one we're talking about a scooter that's 3.5 feet long, and we know the scale is 1 inch is equal to 3/4 of a foot. All right, so we're going to start with drawing over actual, and the two dimensions in the scale are inches and feet, so we're talking about inches and feet. The first fraction comes from our scale, so 1 3/4, that's a terrible 3. Let me try that again, 3/4 equals. Now 3.5 feet, that goes on the bottom because feet are on the bottom, and we're putting x on top. We're trying to find the length in the drawing. So we have 3/4 times x, so 3/4 x. And then we're going to do 1 times 3.5, which is 3.5. Okay, we're going to solve. We got to get rid of that 3/4. So we're going to divide both sides by 3/4. So we're going to take the calculator and do 3 ABC1 ABC2 divided by 3 ABC4. Now that gives me 4 2/3. Now that x is on the top, so we're talking about in the drawing, which would be labeled as inches.